Okay, number 7. One of the most commonly missed questions here. Let's look at it. They give you a table. They love giving you these tables, so you've got to know these things. They're testing to see if you understand derivatives without being given an explicit function. So h of x is equal to the natural log of f of x. Find h prime of 3. So we do need to find the derivative. The derivative of the natural log is 1 over what's inside the natural log, but here's the part we forget, times the derivative of what's inside the natural log, so times f prime of x. So h prime of 3 would be 1 over f of 3 times f prime of 3. I know you were doing this on the computer, but when you get on the final exam, mark all over these things, okay? F of 3 is 5, so that's 1 over 5 times f prime of 3 is 4. So 4 over 5 is equal to 0.8. So the most commonly missed answer, guess what, was just the 1 over 5. So you forgot to multiply by the derivative of what was inside the natural log. They love chain rules on these. Okay, they love chain rules on these questions. So be thinking that if you see a question like that, think, do I need the chain rule here? All right, number 8. Oh, this one made me sad. Second fundamental theorem of calculus here, taking the derivative of an integral, so we know that it undoes it, but there were 2 common mistakes on this. We plug in the limit, but because the limit was squared and our variable was squared, I think we forgot that we had to apply that. And then the other half of us forgot to multiply by the derivative of that limit. So it should be 2t over 1 plus t to the 4th. Okay, that's the correct answer. But notice these 2 answer choices right here had those 2 common mistakes. Either you did remember to multiply by the derivative of the limit, but you forgot to apply that squared to something that was already squared. Or you remember you got the squared part, but you forgot the derivative of the limit. All right, on this one, f of x is equal to x squared, then f of x has a minimum value on which of the following intervals? Now, this question came from a previous test because a lot of you missed it on the previous test as well. Now, we're used to looking at this from an algebraic perspective, and we most definitely can. But let's look at this. X squared is a really easy function, right? Let's just look at it. X squared. We know that that's what it looks like. It goes through the origin, 0 is 0. We know that that's the minimum of the function. That's the absolute minimum. So it most definitely has a minimum on the interval from -1 to 1. So obviously all the answer choices have 1 as a selection. So really we don't have to worry about that. The question is, what about these other 2? From 2 to 3. So if I'm looking at this graphically, from 2 to 3, I'm talking about from the point 2, 4, but it's not included. It's a parenthesis, so it's not included there. And the point 3, 9 up here on my graph, again, it's not included. So remember, when the endpoints aren't included, we can't have a minimum or a maximum value on that interval. But look at that last interval, from -5 to -2. So we've got -2 right here. That one's included. -5 up here, that's not included. But wouldn't that be a minimum down here at -2? It indeed would be. Let's look at this from the algebraic perspective as well. We need to take the derivative, find our critical number, set it equals 0. So x equals 0 is a critical point. We know that. Sign test, 0, -1, +1. Plug it into the derivative. We get negative. We get positive. So that is a minimum. Okay, so again, confirming -1. The interval from -1 to 1 contains a minimum value. 2 to 3, we shouldn't even consider it because it's an open interval. Unless your critical point is in that interval, which it's not. So again, throw it out. But the last one, we need to check those endpoints. Find their y values. Find the y value at -5, that's 25. Find the y value at -2, that's 4. This one was included, okay? That was the bracket. That one was the parentheses. So if 4 is included, it is less than 25, so it does have a minimum on that interval. But I wanted to show you the graph because sometimes the algebraic part, the -5 to -2, that's a little hard to comprehend sometimes. But if you have that visual, I think it makes a lot more sense. So if it's a simple function, there's absolutely nothing wrong with just drawing the picture and looking at it from that perspective. Just because it's calculus doesn't mean that you have to do it algebraically or have to have some numeric justification for it. This is a multiple choice question. They have no idea how you justify it. It doesn't matter as long as you can get that correct. Okay, let's look at number 13. Guess what? I just tweaked this from the review to see how many people were actually going to pay attention, or if you were just going to regurgitate what was on the review. Guess what? I'm not dumb. All right. So on the review, I think that it was decreasing and concave down, but this one is increasing and concave up. So whenever they give you something, just a generic description like that, and they don't give you a specific function, draw a sketch. Increasing and concave up. Okay, we know that the integral from 1 to 3 is going to give us the exact value. The left Riemann sum, let's draw it. If we start on the left side of our increasing and concave up function, here's what we're going to get when we do these rectangles. Guess what? All those rectangles are under the curve, so that's an under approximation. If we do the right-handed rectangles, whoops, not up there. And we start from the right side, guess what? We've got over approximations. The trapezoidal approximation, remember, is about the closest that we could get to the exact area under the curve, so that's not going to be it. It's got to be the right Riemann sum approximation. Okay, number 15. Piecewise functions. I think we're finally getting used to these piecewise functions and the questions that they ask us about. But let me take a step back from this question for just a second and talk about the other situation of a piecewise function. What if we have this? What if we've got -x when x is less than 0 and the square root of x when x is greater than or equal to 0? So if I sketch that out really quick, I've got the line over here on the left side. I've got the square root function here on the right side. So let's talk about these statements asked about in this question. At 0, though, let's talk about 0. Does it have a limit at 0? Well, sure. It's headed towards, from both sides, it's headed towards the same value of 0, 0. So it has a limit. Is it continuous? Well, yeah. The two pieces meet. They have the exact same y value at 0. Is it differentiable? Well, hopefully you remember differentiable. If it's continuous, usually it is differentiable, except for sharp points and vertical tangent lines. Well, that looks like a sharp point, but let's verify it algebraically. If I take the derivative of the first piece, the derivative of the first piece is -1. The derivative of the second piece is 1/2 x to the -1/2. I want to know the derivative at 0, so I plug in 0. Well, when I plug in 0 right there, I get 0. So my derivative has two different values at 0. The left side has a derivative of -1, the right side has a derivative of +1. So it's like with limits, if your derivatives don't have the same value, then it's not differentiable. Okay, so that's one case in piecewise functions. The other case with piecewise functions is the scenario of a hole, and that's what we have here. Okay, we've got a rational function here when x is not equal to 2, so everywhere but at 2, we look like this rational function. Now let's learn something a little bit more about this rational function. We can simplify it. We can factor that numerator. We can cancel the x minus 2's. So our function is behaving like x plus 2, but there's a hole at x equals 2. So what would be the y value of that hole? We'll plug it into the simplified version. 2 plus 2 is 4. Well, guess what? That's the other value of our equation. That's the other piece of our piecewise function. So I'm going to graph this piecewise function. So my rational function looks like this, except it has a hole. It just looks like the line x plus 2, but it has a hole where x equals 2. Well, guess what? When x equals 2, according to this piecewise function, the y value is supposed to be 4. It plugs the hole. So let's look at our statements. Do we have a limit? Yes. We are headed towards 4. Is it continuous? Yeah. The hole is plugged, so it's continuous. Is it differentiable? Yeah, it's a straight line. The value of the derivative is the same from both sides. Take the derivative of the top. The derivative of x plus 2 is 1. Well, that's not a good example. Never mind. Don't worry about that. I don't know what I was thinking there. That doesn't apply. Left side and right side. But it's continuous. There's no sharp point. There's no vertical tangent line, so it is differentiable. So all three of these statements are true. All right, number 16. We're getting into the calculator active part of the test here. So let f of x be a continuous function such that f of 1 is equal to negative 11 and f prime of x is equal to the square root of x cubed plus 6. What is the value of f of 5? So once you think about it for a minute, I think that most people, we've gotten used to the idea if they give us some kind of condition, they give us a derivative and they're asking us about another value, then we know that we take our starting point, we add the integral from where we started at 1 to where we're wanting to be at 5 of a derivative. That's going to give us our answer. Now, calculator active portion of the test. I don't care if that function is as simple as just x. Yes, I know you can integrate that, x squared over 2, plug in your limit, subtract, but why do all that work, take all that time, and risk making an arithmetic mistake when your calculator will do this? Now, if you have an 89 that looks a little bit different than this one, but the 83, guess what? It'll do it. So I'm going to type it in, negative 11 plus math. On the 89, it's under the calc menu, F3 calc for calculus. But we scroll down here to number 9, Fn int. Guess what? Fn is function, int is integration. Hit enter. Type in your function, square root of x cubed plus 6. Close your parentheses for your square root. Don't close these parentheses yet. Comma, x, you got to tell it what to integrate with respect to, comma, lower bound, comma, upper bound. Now close your parentheses. You don't have to close the parentheses on the 83, you do have to close them on the 89. Now the thing I love about the 89 is that when I press enter here, it's going to print out my answer exactly like I have it written on my paper, and honestly, that's the first thing I look at. I do not look at the answer first. I look at how did it interpret my function to make sure that I have everything typed in correctly. Then I look at the answer. But this is the correct answer there on part B. So again, let me reiterate. I don't care if it's something as simple as the integral from 1 to 5 of x. If it's on the calculator active section, use your calculator. Let it do the hard work for you. Because they're not testing, they're not testing you to see can you integrate x. They're testing you here to see do you understand the accumulation function of the integration function. Okay? All right. Now, 26 killed me when I saw that only 2 people got it right. But I think I know why. It's because when you're reading the problem, you see the graph of the derivative function f. You see f and you think that this is f right here. Did you ignore the words right before it? The derivative of a function of f is shown in the figure above. So when I'm reading this question on the exam, I am immediately, as soon as I read that statement, I'm going up to that picture and I am labeling it with what it is. I am automatically labeling it with what it is so that I know, okay, I'm looking at the derivative. All right, now what are they asking me about? The graph is horizontal tangent lines at -1, 1, and 3. Okay. At which of the following values of x does f have a relative maximum? So as soon as I read that, knowing that I'm looking at the derivative, I'm going to write this. I'm going to say f prime positive to negative. Because where f has a maximum, f prime is going to change from positive to negative. So I'm looking positive, negative, that's at 4. Okay, now look at what the majority of people answered. -1 and 3. What are those? Those are the maximums of what you're looking at. Do you really think that they would waste a question on the AP exam for you to look at a graph and just identify where a maximum occurs if you're looking at the graph of what they're asking you about? No. I'm not trying to be sarcastic. I'm not trying to make you feel bad. I'm trying to point out that if you get to a question on the AP Calculus exam and it didn't require you to do any calculus, you need to go back and double check, because they're not going to waste a question on that, okay? If you did not have to do any calculus to answer that question, you need to go back and double check and make sure that you aren't missing something, that you're not missing some detail, that you're not overlooking something, because you're going to have to do calculus on all these problems. So keep that in the back of your mind. Okay, 27. The position of a particle moving along the x-axis at time t is given by this. They give you the position function. At what time is the particle's instantaneous velocity? So instantaneous velocity is the derivative of position equal to its average velocity. So when I see average value, average anything, 1 over b minus a, integral from a to b of what they're asking me about, of velocity. So it looks like I need my velocity function. Very easy to find. Take the derivative, negative 3t squared plus 4t. Okay, they want to know where's the instantaneous velocity equal to the average velocity. So I'm on this interval from 0 to 4. So how about I find my average velocity? 1 over 4 minus 0, integral from 0 to 4 of my velocity function. Again, use your calculator. Use your calculator, use your calculator, use your calculator. Don't do this by hand. Don't risk making a mistake. Okay, and we get that that's equal to negative 8. That is the average velocity is negative 8. So we want to know, when is that equal to our instantaneous velocity? So how about we set that equal to our instantaneous velocity? Now it's a quadratic. We would love if it was factorable, but guess what? It's on the calculator active section of the test. They love to put ones on there that are not factorable. And look at the answer choices. There's only one that's a whole number. Okay, there's only one that's a whole number. So chances are it means this is not factorable. We're going to have to rely on our calculator. Now, on the 89, there's a solve feature under the algebra menu, F2 algebra. It's solve, so you do solve, you type in your equation. It doesn't matter which way you have it in there, left side, right side, it doesn't matter, equal to 0, not equal to 0. I just type it in just like that. Don't risk trying messing something up. Oh, and I would use X's. And comma X, that's all you have to type in. You type that in, you press enter. Now, it does actually use the quadratic formula, so it will give you the answer in square root form. So as soon as it gives you the answers, hit diamond and press enter, and it will give you the decimal approximations. Now, here's the other thing you have to be careful with. It gives you two solutions. Now, fortunately, in this case, one of them is negative. But I do believe that it's negative 1.097, so guess what? That's why they put that answer choice on there, because a lot of people are going to look at their calculator, and that's all they're going to see. They're going to ignore the negative in front of it, and they're going to select that first answer choice. So you got to make sure that you pick the one that's in the interval between 0 and 4. So if it gave you 2.431 and I don't know, 6 point something, okay, the 6 point something is not in the interval, so that's not applicable. Usually they'll try to throw you off with something that shows up first to make sure that you're paying attention to whether it's actually in the interval or not. Okay, let's look at that last free response question. Okay, we need to find both the time and the position of the particle when the particle is furthest to the right. Anytime you see words like farthest or most or highest or greatest, you should be thinking extreme value, so you need critical point and endpoint. So we're looking at velocity. We're talking about the extreme value of its position. So guess what? Velocity, critical points, where it's equal to 0. So that happens here at 0, at 3, and at 5. 3 is a relative minimum. 5 is a relative maximum. Since it wants to the right, that would be max. Okay, furthest to the right would be maximum. Furthest to the left would be a minimum. That's our critical point, 5. We also need to check endpoints. So we need our position at time 0, our position at time 5, and our position at time 6. Our endpoints and our critical point. That could be the applicable maximum or extreme, excuse me. All right, so we've got negative 8 here, We've got 3 here and -2 here. So we start at -2. Its position at time 0 is -2. We start at -2, we go -8, we go +3, so that's -10 plus 3, that's -7. And then we go 2 more to the left, so that gives us -9 for the position at time 6. So a lot of people gave me the answer of -7. -7. Negative is on the left, okay? It does not make sense for that to be the time when it's furthest to the right. We're moving along the x-axis, so let's think about this. We start at -2. That's the starting point. We move left 8 units, so we end up at -10. Then we go right 3 units, so we end up at -7. Then we go back left 2 units, so we end up at -9. So when was it actually furthest to the right? At -2. Always write that in a sentence whenever they do this. Your justification is your positions over here. And then you need to write it in sentence form. The particle is furthest to the right at time t equals 0 and position x equals -2. Now, I'm not going to go over part B. Most everybody got that one right. I kind of just explained it, actually, with my little purple diagram up there as far as why it crosses -8 3 times. Okay, part C. On the interval from 3 to 4, guess what? When I read this, I'm going up to my picture and I am circling the part of my graph from 3 to 4 before I even read what it's asking about. Is the speed of the particle increasing or decreasing? Okay, yes, it's good if you think speed is the absolute value of velocity, which it is. Speed is the absolute value of velocity. But if they're asking you, is the speed increasing or decreasing, that is the same as speeding up or slowing down. So you should think signs of velocity and acceleration. So on this interval, velocity is positive. And acceleration, how do we determine the sign of acceleration? Well, acceleration is the derivative of velocity. So velocity is increasing on that interval, so acceleration is positive. So since they're the same, therefore, you can use those 3 little dots in a triangle for therefore. The speed of the particle is increasing. Now, I don't think you really need to, you have to say on the interval from 3 to 4, but it can never hurt, right? So that was, most people answered this and just said that because velocity is positive, then the speed is increasing. It's not the case. You have to establish the sign of both velocity and acceleration. Remember, when they're the same, it's speeding up or the speed is increasing. When they are opposites, then it is slowing down or the speed is decreasing when they have opposite signs. All right, last part of the test here. During what time intervals, if any, is the acceleration of the particle positive? So I'm thinking, I'm looking at velocity. They're asking me about acceleration. So acceleration is the derivative of velocity. So where that's positive acceleration means velocity is increasing. So where is my velocity increasing? It is increasing right here. Now, a few people said it was between 2 and 4. Be careful. Look at what they tell us. They tell us we have horizontal tangents at 1 and 4. So where we have a horizontal tangent is where we actually have the change. So from 1 to 4, because velocity is increasing on this interval. Okay, so just be careful with that. I'm telling you, I can almost promise you that there will be a particle motion free response question. They love them. It's just such a stereotypical calculus problem that you can expect to see it on the exam. Now, if you don't, I'm sorry. But I'm saying this to make you realize you've got to understand position, velocity, acceleration, particle motion. You've got to understand those contexts, those applications, because if it's not a free response question, you're going to have at least one multiple choice question that addresses these concepts as well. So if you need help with it, come find me, talk to me one-on-one about it. Look up a video. Khan Academy has some great stuff. Look it up. Just find some answers for yourself. Because I guarantee you, you're gonna encounter this in one way or another. So make sure you're prepared for it. Okay. That's all that I wanted to address as far as the most missed, most frequently missed, most commonly missed, whatever you want to call it. But if you have questions about any of the other ones, feel free to text me. I'm going to put these test corrections on second 6 weeks. So I'll give you the exact due date for these soon, but it won't be until next week.